Okay, good morning, everyone. I can see the red button in the corner of my screen. That means we're recording and I think ready to make a start. So you're all very welcome to this webinar this morning, this Foresight webinar, where we'll be discussing all things hydrogen to power this morning. My name's Tiernan Phipps. I'm from Foresight Events. Delighted to introduce this session, sponsored by the Foresight event, our all-energy clean tech show taking place next February. Over the next hour, as I mentioned, we'll be exploring how hydrogen is emerging as a vital tool for the transition to a decarbonised power system, helping to balance renewables, replace fossil fuels, and also accelerate the UK's clean energy transition as a source of low carbon dispatchable power. This webinar is also in partnership with the Northwest Hydrogen Alliance. And it, of course, comes off the back of their extremely informative Hydrogen to Power 2025 report in the summer, which looked to provide a blueprint for realising the potential of hydrogen to power, particularly in the Northwest. But today we'll be discussing that and other regions in the UK too. Its recommendations as well, I'm sure we'll get into today as well. So a great lineup today. We have Adam Baddeley, who's Head of Project Development at Progressive Energy. We have Marta Csibra, Head of Strategy and Business Development at EET Hydrogen. And alongside Marta and Adam, we're also delighted to be joined by a couple of colleagues from the Department for Energy Security and Net Zero. So we have Jessica Young, who's Hydrogen to Power Policy Lead, and also Matthew Pugh, who is Hydrogen to Power Business Model Implementation Lead at the department. So Jess and Matthew, thank you very much indeed for joining us as well. Even better, it's not me moderating today. You'll be happy to know. Delighted to introduce Floyd March, who is Northwest Correspondent at Energy Voice as well, who will be guiding us through the discussion today. Floyd is a native to the Northwest and also extremely interested in hydrogen. So Floyd, delighted to have you leading the session today as well. So we'll get started, and Floyd, I'll hand things over to you. Just a reminder to everyone, please do feel free to pop your questions into that Q&A button at the top of the screen throughout the session this morning, and we'll pick them up in the Q&A session. But apart from that, that's all from me. Floyd, I will hand over to you now. The floor is yours.
Brilliant, thank you for that, Tin. And you've set up the scene for the webinar, so I don't have to do that awkward first 30 seconds of the webinar where I kind of like rattle through all the introductions. So yeah, thanks for having me on. I think that the best thing that we can do before we hit the Q&A session is just set a bit of context for the webinar today. So maybe if Jessica, you come in first and kind of set the scene from a DESNZ perspective, and then we'll speak to some of the other people on the panel.
Sounds great. Hi everybody, as trailed, I'm Jess. I work in the Hydrogen to Power business model team in the Hydrogen Directorate at DESNZ, and I'm joined by my colleague Matt as well. Just a quick note to say, both looking forward to taking your questions later, but if there are, we are a small part of the team in the Directorate, so if you do have questions that we're not able to answer now, because it's not our area of expertise, then we're very happy to reach out to colleagues across the department after the call and provide follow-up responses once we do have an answer. Probably also worth highlighting at the outset that we're not able to share lots of new, exciting, shiny new information at this point in policy development. More information is coming, but I'm not able to share a huge amount at this stage that's not in the public domain. That said, I can give a brief overview about the backgrounds of the hydrogen to power business model, why we think hydrogen to power is important and it contributes to achieving the department and government's core objectives, and provide a bit of a summary on work to date and what the government's been up to this year and what's coming up. So without further ado, when the government was elected last year, it announced that one of its core 5 missions was to make Britain a clean energy superpower, and it published the Clean Power Action Plan last year to explain how it would deliver this. We expect that a clean power system will require a range of flexibility provision and system services to ensure that the power system is secure and stable with electricity demand and supply balanced at all times. Whilst we expect renewables to form the cornerstone of a future decarbonised power system, long duration flexible technologies like hydrogen to power will be critical to maintain electricity supply to manage long periods of either low renewable output and or higher electricity demand. Hydrogen-fueled electricity generation, or hydrogen to power, is one of the few forms of low-carbon, ultra-long dispatchable generation technologies, and therefore can play a really important role in supporting the delivery of the clean energy superpower mission. Another benefit of hydrogen to power is that it can deploy at a range of scales and in a range of archetypes, from reciprocating engines to open cycle and combined cycle gas turbines, as well as fuel cells. It can provide a decarbonisation pathway for new unabated gas generation. And when connected to large-scale hydrogen storage, assuming a build-out of wider hydrogen infrastructure, it can enable interseasonal low-carbon electricity storage. Hydrogen to power also has benefits because it's cost effective at relatively low load factors and below 30% based on all of our kind of internal and external analysis. And so that means it can provide a key role in a post 2030 power system, since greater renewable deployment we expect will reduce the running hours for flexible capacity. It's also expected to be a key demand sector for the future hydrogen economy, and it will be reliant on enabling hydrogen infrastructure, especially storage, but also production and networks. In terms of government's approach to supporting this technology, we've taken a bit of a three-pronged approach. So after consulting on the need for bespoke intervention at the end of 2023, we confirmed our commitment to developing a bespoke business model to support hydrogen to power projects last December in the government response to that consultation. We also committed to enabling hydrogen to power projects to compete in the capacity market as soon as practical. And there is a live call for evidence out now. It's been published in October, so please do respond to that. And thirdly, in March of this year, we published a call for evidence on innovative hydrogen to power projects to understand industry's potential for accelerating innovation and to make rapid progress on the first generation of hydrogen to power projects. So I can talk briefly a little bit more about the business model, because that's what we work on. We determined a few years ago that it's unlikely that the current market arrangements will deliver significant investment in low carbon flexibility required to decarbonise the power sector, particularly at the pace required to deliver the government's clean power mission. Our internal and external analysis identified two key barriers which might limit the deployment of hydrogen to power projects. Firstly, uncertainty and increased investment risk from being a first-of-a-kind technology. And second, the dependence on nascent critical enabling infrastructure, i.e. hydrogen production, transport and storage, creating cross-chain risk in the short term, both of which exacerbate the cost of capital and make it quite challenging, especially for large projects, higher capex projects, to compete in a capacity market as a route to market. We determined that a dispatchable power agreement style mechanism like that used to support power CCUS projects would be most suitable to support the deployment of hydrogen to power projects compared to other potential mechanisms, and feedback from respondents to the consultation was overwhelmingly supportive of that position. That's due to its greater ability to manage cross-chain risks from a nascent hydrogen value chain compared to other models, especially since it doesn't have the non-delivery penalties of the CM, but also encourages the generator to participate and respond to power market signals effectively and efficiently. It will provide regular payments to help hydrogen plants compete in energy markets, ensuring a stable and reliable capacity and critical system services for the secure power grid. So we committed last year to provide a bespoke market intervention in the form of a business model that would be based on a DPA style agreement to support hydrogen to power projects. We intend to publish a market engagement document in due course, providing further detail on the design of that business model, how the competition will work, and ultimately how the payment mechanism will work. We are working closely with colleagues across the department, including in the production business model, storage business model and transport business model, to ensure optimal alignment in the design and delivery of subsidies across the value chain. And we are working with colleagues in power CCUS as well to take lessons from their experiences and consider the impacts and interactions between power CCUS and hydrogen to power. Unfortunately, I can't say a huge amount more on the design at this point, but a very quick kind of progress update about what's happened this year and what's coming up. At the beginning of the year, we introduced legislative changes to ensure that new build and substantially refurbished power plants in England are built with a viable route to decarbonise, so decarbonisation readiness work. And those requirements come into force in February 2026. We established a working group for hydrogen to power, a forum to test policy proposals with industry. Again, if you're interested, please do reach out. I can put our email address in the chat afterwards if you don't already have it. We published the Innovative Hydrogen to Power Projects Call for Evidence in March, as I mentioned, which closed in May. We are analysing responses and plan to respond in due course. The spending review, of course, confirmed over £500 million worth of support for hydrogen infrastructure, which will enable the development of the first regional hydrogen transport and storage network. It's very exciting. The industrial strategy published in June, confirmed that we aim to launch the hydrogen to power business model in 2026, and that we'll also be launching the transport and storage business models in 2026. And as I mentioned, this month the department has published a call for evidence on the inclusion of hydrogen to power in the capacity market. So please do respond to that if you have views. Finally, next steps, as you're aware, we have committed to publish a refreshed hydrogen strategy that will set out this government's view of hydrogen and the value and role that hydrogen has to play. That's coming soon, can't say a huge amount more than that. And the hydrogen to power business model market engagement document outlining further details on the proposed design of our business model will also be published in due course. We intend to continue to engage with the market through our expert groups as well. So if you would like to get in touch, please do at our email address, hydrogenpower@energysecurity.gov.uk. I think that's everything. Apologies, a bit long.
No worries. Thanks for covering that off, Jess. And yeah, maybe I'll bring in Adam at this point, just to talk us through the world of progressive energy and the lens that you guys have on hydrogen.
Yeah, sure. Thanks, Floyd, and thanks, Jess. Good to have government on the session, and hopefully we'll get into a good discussion later on. So yeah, just a bit more about myself. So I was one of the originators of the HyNet project in 2016. So I sort of like to think I know my way around the Northwest and hydrogen. I wear sort of several hats now. A director of Grenier Hydrogen, which is Progressive's electrolytic hydrogen joint venture with Statkraft and Foresight, a different Foresight to the organisers of this event. A lot of what I've been doing over the last sort of 9 years is focusing on hydrogen use, so a lot with industry, so running a lot of commercial scale demonstrations with the likes of Unilever and Kellogg's, etc., and putting in stage early commercial agreements with those entities as part of the HyNet project, but focusing more on power generation over the last year or so, particularly since the sort of CP 2030 mission has come about. And some of you may have seen probably 6-9 months ago, we launched a sort of, or went public on some joint working we're doing with ESB, that own Carrington Power Station in Manchester, towards developing a suite of hydrogen to power projects in the Northwest. So Progressive is essentially a project developer, originator, and we're sort of focused on a number of things, including obviously hydrogen to power. I'm not going to say a huge amount. I think hopefully we'll get into a very good sort of Q&A as we go through the session. But I will say, I think, as I said, CP 2030 is a real driver for hydrogen to power, and that seems to have changed, I guess, the landscape in respect of how we can deliver dispatchable power to fill in those sort of gaps when the sun isn't shining and the wind isn't blowing, etc. And I think really in those sort of reports that NESO and DESNZ put out a year or so ago, it really showed the benefits that hydrogen to power can deliver to the energy system by reducing some of the, I think we had one figure whereby there was, I think, delivering about 5 gigawatts of hydrogen to power would reduce the need for sort of 16-17 gigawatts of wind and BESS, etc., with the financial benefits that delivers and reduction of costs to the energy system and therefore energy consumers and government. I will say, I mean, hydrogen to power, the development of the H2PBM has been perhaps a little bit slower than we might have liked. There's a lot of challenges I recognise for the government to get over in that. It's difficult to sort of determine how that mechanism is going to work, when and how that is going to marry to all the hydrogen TNS and the other sort of mechanisms that government needs to and is putting in place. I think there's some interesting proposals coming out in relation to the capacity market. We can perhaps talk about those later. More in relation to, there's a consultation that was published alongside the call for evidence that's looking at a sort of almost two-tier mechanism associated with the capacity market, which may be interesting for hydrogen to power. I think just to conclude what I'm going to say, I think this is a fantastic discussion, but all this is dependent on having some hydrogen. And thankfully, we've got Marta here, who's probably going to talk next. We can't do anything in the Northwest without having any hydrogen. Critically, we also need the transport and storage infrastructure, which Cadent and Storengy are hoping to put in place. And all of this needs to go through the sort of competitive processes that are at play with and coming, we hope, in 2026, which will enable, deployment in the sort of, I guess, at scale in the early 2030s. So lots to talk about, and looking forward to getting into the Q&A. Thank you.
Yeah, for sure, Adam. I think it's going to be hard to keep it keep it to time with all the things that we could talk about. So yeah, just as a reminder, before I introduce Marta, that yeah, you can drop your questions either in the chat function or the Q&A function. Yeah, forgot to mention that one. So yeah, Marta, if you'd like to just give us a couple of minutes introduction.
Sure. Hi all. So I'm Marta. I'm the head of business development for EET Hydrogen. For those of you who don't know us, we're part of the EET, or the SR organisation that owns the Stanlow refinery in the northwest, and we're developing low carbon hydrogen production plants located at the Stanlow site. So we are sitting at the intersection of the CO2 and future hydrogen infrastructure within HyNet, because our hydrogen production is primarily going to be CCS enabled, which means we need access to the CO2 TNS and ENI's Liverpool Bay to store the CO2 that our hydrogen production will create. I guess we have kind of an influence and input into H2P in kind of two ways. So our first project, H2P1, which is a 350 megawatt plant, will support a slightly different kind of H2P than we're talking about, which is we are building a on-site CHP, which will provide baseload hydrogen-fired power for the refinery, and potentially some nearby local off-takers as well. So that'll be the UK's first hydrogen-fired CHP. But broader than that, our second project, HPP2, which will connect to the wider hydrogen transport and storage network, will provide the opportunity for significant volumes of hydrogen to support H2P in the region. And in that case, we're talking about dispatchable low-carbon generation to support the wider energy networks. So really excited to be involved in that, and there's kind of lots of different levels of interest, both existing plants that are converting to hydrogen use and also new plants being developed in the region, which we're hoping to support. I think, as Adam mentioned, obviously we need the transport and storage to be built to support that, to be able to get the hydrogen from our production sites to the various uses. And I guess I'd say that you know, hydrogen to power is very valuable in the UK, and we've all talked about the context of that. But really, there's only two places in the UK to execute that in the next few years, and that's either in the northeast or the northwest, because that's where we expect large scale hydrogen storage, which is essentially critical to support the hydrogen to power with the level of hydrogen and consistent level of hydrogen it needs. I guess just a couple more reflections. Obviously, we've had a bit of an intro on the policy side. Obviously, policy is driving lots of the progress and pace and decisions at this point, given the interaction between the hydrogen production business model needed to produce the hydrogen to put into the system, the transport and storage business model, which is going to be decided next year, which obviously will move the hydrogen around, and then the power business model. So that obviously creates lots of interactions with government, and essentially, you know, the private sector is kind of reliant on pace and progress in that side to be able to move forward with these projects. I think finally, to succeed and for H2P to succeed, what does it really need to be able to do? It needs to be able to demonstrate that it can provide value to the electricity system by providing the flexibility at low cost and ensuring that we can decarbonise as much of our electricity system as possible. And I think there's already clear guidance that it has the capacity to do that. Obviously, we're going to be looking at H2P at high blends of hydrogen. So we're not talking about 5%, 10% hydrogen blends. We're talking about much higher levels to demonstrate the scale of the decarbonisation impact that's possible. And finally, really, the H2P assets need to be able to run optimally and commercially, such that we're not distorting the system, and the associated value chain infrastructure across storage and production also needs to be able to run optimally and commercially to ensure that we have the most efficient system at the lowest possible cost. Floyd, shall I pass back to you?
Yeah, sure. Thank you for that. I've got a couple of context-based questions just whilst the audience gets warmed up with their Q&As. So a bit of a sledgehammer question straight away. So maybe I'll bring Jessica and Matthew in on this one. Is there a risk that policy and market frameworks still view hydrogen primarily as a fuel for industry rather than a power sector enabler? And how do we kind of change this perception? Is it through policy frameworks like you've mentioned earlier? Maybe bring Jessica and Matthew in first.
Yeah, sure, we can have a start with this. I mean, as I think we've trailed before, clean power is at the heart of government's kind of objectives. I think it's very clear that it's very high on the priority list. So I don't think we're at the risk of the department not seeing the value of hydrogen in a power context, and I think our business model is proof of that. I will say, as I mentioned before, that we are planning on publishing a refreshed hydrogen strategy very soon, which will address some of these questions about what we think the kind of optimal role and value of hydrogen is. So I can't speak much more about the specific narrative in that, but it will address these questions. And I would say that I think power and clean power is definitely at the heart of what the department is aiming for and what the government is aiming for, and sees hydrogen playing an important role in that. Matt, is there anything you want to add or amend?
Thanks, Jess. No, nothing to add to that. That was a really good answer. Yeah, I'm happy to leave that one. Thanks, Floyd.
Yeah, sure. And Adam, maybe I'll bring you in here from a progressive energy perspective. You know, how important is it that hydrogen is seen as a power sector enabler and not just a fuel for industry?
Yeah, I think government's been pretty clear in the last sort of 6 months or so as to where it wants to direct, hydrogen at scale, and that I think in respect of industry, richer parts of industry which struggle to decarbonise via other means, they can't be easily electrified, but also as I said with the clean power mission and CP 2030, clear policy signal, the government sees the power sector as something that would clearly benefit from low carbon hydrogen to displace the dispatchable natural gas that's on the system, which can't be done easily or cost effectively by things like batteries. So yeah, I think the policy signals are there. It's just getting that the detail, the mechanisms to make that happen in place.
Yeah, sure. Thanks for covering that off. And Marta, I'm not sure if you have anything to add on that topic.
No, I agree with everything that's been said. I guess sometimes the focus for hydrogen is industry, and I think that's primarily just due to a timeline challenge, right? It's been slightly easier for industry to move slightly quicker on this, and that's because obviously there isn't an industry-based business model for the use of hydrogen within industry, and there's been some support through the IETF funding, etc. So and I guess the other point is that hydrogen production kind of up till now has been very much focused on being located at the point of use, whereas that's not necessarily expected to be the case going forward, and that's definitely not the case for power given the need for large scale storage. So it's been a little bit easier for industry to move first, but I think it's clear that power is as important a lever and demand pool for hydrogen as industry is going forward.
Yeah, definitely. And I'll come straight back to you, Marta, here. So obviously the business model is still in development, but from an industry perspective, what would you say the key design principles crucial for its effectiveness in driving investment would look like?
I guess if there's one thing, it's really just understanding early with as much clarity as possible what the kind of risk reward balance is. So there are lots of different business models, right, and they all have interactions with each other, and the more you connect the value chain, the more interactions they have. So really from a power perspective, it's understanding who's taking what risks and who's bearing what costs, right? And that helps you understand what the commercials look like. It helps you understand what the business case is for each part of the value chain. And I guess there will also be the kind of structure of a hydrogen network code that will bring this all together as well and ensure that those risks and communications flow in the right way. So I think as an early critical path, it's really understanding that and where it sits.
Yeah, sure. And Adam, I'm sure you echo those same sentiments, but I'm not sure if you had anything to add from industry.
Yeah. I mean, in terms of design principles of the H2 PBM, and apologies, I hope everyone can hear me. My connection might be a bit dodgy. It's early half term here, and kids seem to be streaming things, even though I told them not to. But I think let's just start by acknowledging that with hydrogen to power dispatchable generation plants, the load factors are going to be relatively low going forward, and those are going to get potentially eroded over time. As more renewables come onto the system. So there needs to be, and I think government has talked about following the dispatchable power agreement model, but there needs to be some form of availability payment as part of the H2 PBM, and that which sort of largely covers capex and fixed opex to de-risk investment. And that needs to be of sufficient sort of size to give a a rate of return that reflects risk when we're only operating, a small number of hours in the day. There's also been discussion about a variable payment and whether that's necessary. I think we've had a lot of discussion with government about this issue and looking informally at how the design is undertaken. But whether a variable payment is needed to enable us to sit above natural gas in the merit order or not. I think hydrogen to power does avoid ETS costs, and therefore potentially a variable payment won't be needed, but that'll depend on the particular application. I hope you managed to hear all that. The connection was okay.
Yeah, we got it this time, Adam. Thank you for that. And Adam drew on that on parallels or lessons from dispatchable power agreement for CCS. So just a question for Jessica and Matthew, are there any of those parallels or lessons that have been learnt from there, and can we see any of those shaping the HU BPM?
Yeah, it's a good question. So we have selected the DPA style model for a reason. I think that's the most suitable type of investment model for hydrogen to power projects, but we are conscious that the CCUS context is different to hydrogen. CO2 TNS is different to hydrogen production, transport and storage networks. They behave slightly differently. They have slightly different subsidy mechanisms. So we are currently in the process of understanding which elements of the DPA are appropriate to bring into the hydrogen to power context, which ones are maybe kind of, dysfunctional. How do we ensure, as mentioned before, that we get the kind of maximum decarbonisation benefits, but we also have optimal system integration. We also have the generators being incentivized to operate kind of optimally and in a value for money way in the power market. So we spend a lot of time talking to the power CCUS teams and understanding how they formulated the DPA and also how they run the CCUS cluster sequencing process and what the competition looks like. So we try to take as many learnings from that as possible, but we are also conscious that the CCUS world is slightly different to the hydrogen world. So sorry, I can't provide a huge amount of detail about what that's going to look like, but we are definitely considering those things.
Yeah, definitely. And Matthew, not sure if you have anything to add on to that.
Sure. Just to say, I mean, I agree with what you said there, Adam, about reflecting the need for covering what we call the missing money, so the availability payment for low load factor plants. Obviously, the power CCUS DPA was designed specifically on the back of the capacity market, which itself was designed to cover that missing money with renewable deployment coming forward. So I think we're definitely live to that, and obviously the business model will be designed with that very much in mind. I think we're committed to an availability payment of some kind, and as Jess said, I think it's just working through the details of how we would ensure that hydrogen to power dispatches in the most efficient and effective way possible, and what the right mechanisms are for encouraging that. But yeah, I think definitely would echo what Jess said there.
Yeah, thank you. Thanks for covering that off. And obviously we're here to talk about the Northwest, so I'll get into more of a regional angle at the moment. And obviously we're here to talk about hydrogen to power. But I've just got a question about kind of industry shocks, because Scottish Power, obviously, they were successful in HAR1, but have since paused, hydrogen developments. Because a lot of hydrogen developments are quite new, how much of a shock could this be for industry? And from a DESNZ perspective, is how do you contain those shocks where people might think it could be falling apart before it begins?
Is that a question, Floyd, on sort of how do we drive confidence through production business model? I think it's a really good question in terms of how do we ensure that there's momentum behind the hydrogen program as a whole. We were at a Hydrogen UK event yesterday. I'm not sure if others on the call were here, but I think the minister spoke there about the need to ensure there's momentum behind what we're doing. And obviously we signed HAR1 contracts this year. There's always going to be teething problems as we deploy. We can't expect every project to be successful, but I think obviously government's bringing forward the HAR2 process, hoping to say more on that shortly. And I think as we deploy more projects, confidence will build. Obviously, I think it's about spades in the ground and taking final investment decisions that will actually will drive industry confidence. Obviously, to say that there might be some projects that have difficulties, but I think for our point of view, it's designing the right mechanisms and not rushing things immediately so that we push things forward to meet short-term goals that end up having longer-lasting problems that undermine confidence, whilst also mitigating the fact that we need to move forward at pace. So balancing that, I think, is the priority.
Yeah, for sure. Thanks for covering that off. And Adam, maybe from an industry perspective, if we see other projects getting cancelled, do you feel those shocks as industry, or are you guys just like head down and focusing on your project?
I think there are some specifics around that the Scottish Power decision. I don't probably go into today, but I think the electrolytic hydrogen market has been challenging, I think, in recent months. I think there's been a bit of correction. There was a bit of a bubble, I think, early on, and I think some of the sort of more challenging projects are perhaps falling away now. I don't think that's had any influence on the sort of core, HyNet project or the core HyNet infrastructure and trying to get that through to FID. Obviously, the first phase of that CO2 network has got to FID. We're trying to move the following phases through. So I think has that been a shock? No, not really. I think we're all still committed to getting things done. And I think from an electrolytic perspective, and we've got one project in H2. I think there are some larger projects coming forward, including some in the HyNet area. Does that influence hydrogen to power? I think we weren't expecting to get hydrogen from electrolytic for hydrogen to power in the early years. Doesn't make sense to have quite a closed loop system of power to hydrogen back to power. I think at a system perspective later that makes sense, but no, I don't think it's had a huge impact on what we're trying to do in the Northwest.
Yeah, cool. Thanks for covering that one off. And yeah, just to focus on the Northwest for a while now, I feel like skills is the best place to start with that. So what skills do we think are needed to see this vision through? And where are the current gaps? Maybe I'll stick with yourself first, Adam.
Well, I could do with having one of my more supply chain skills perfect. But yeah, I mean, I think HyNet we have a program whereby we work with local educational institutions to try and determine what skills are needed, and there's quite a lot of emphasis and investment going in via the HyNet Alliance in that regard. And I think that goes from anything from the sort of engineers on the ground to those who are sort of, I guess, developing the actual new technologies and systems that need to support future development. So I think it's something we take seriously, but I don't have the knowledge on that area to go into specifics.
Yeah, sure. Maybe I can bring Marta in and the importance of skills in the Northwest and having good local job supply chain.
Yeah, I mean, DESNZ a few days ago published its clean energy jobs plan, right, which highlights kind of the need for a broad range of jobs across technical, commercial, and construction requirements in the Northwest and across the UK. So there's obviously lots of thinking that's gone into that from a DESNZ perspective, and I think there's definitely a view that is required. And that will be delivered across both construction jobs and then in the longer term around operational jobs. And I think there's an element of kind of competition around the construction piece, right? Because if everyone's going to be building different parts of the value chain at the same time, they'll all need the same, the same skills. And as Adam says, HyNet's doing a bit. There's various other programs going through Cogent Skills and others who are trying to elevate the kind of hydrogen and also CCS skills required in the HyNet region. I think the one thing that's not it's fairly consistent across the clean energy sector in terms of the types of skills required. So it's not sort of hydrogen to power requires one set of skills that are very different from, the hydrogen production part of the chain or CCS or anything else. A lot of the skills are very transferable. So I think it's a case of just ensuring that both the existing workforce and the new workforce that comes in is trained and enabled to be flexible to meet the requirements going forward.
Yeah, brilliant. Thank you for that. And just going to bring in Matthew and Jessica here. I've had a question come in from Mike, and he's asking whether you guys see hydrogen providing local on-site power for specific industry sites, feeding from a local network, or do you guys see larger power plants generating for national countrywide grid network?
it restricts it to only one.
Thanks, Floyd. I'm happy to take this one, Jess. I think fundamentally we see hydrogen powered at system level as having benefit as a dispatchable technology. So filling the gaps, as Jess said at the start, about when there's the sun isn't shining, the wind isn't blowing, and you need some kind of sort of energy storage capacity to fill that gap. That's where we see the real system cost value of hydrogen power. I don't think we see we want to necessarily limit hydrogen power's role if it has economic value. I think we're open to people suggesting to us if they do see value for specific roles. I think we would say that we haven't seen analysis yet that suggests that it has a role in sort of like baseload. I think there are other technologies that play that role in a cheaper way than hydrogen to power. But I think if there was justifiable evidence to suggest that it could be economic and commercial in playing that role, that we're open to that. But fundamentally, we see the hydrogen to power's role as a dispatchable technology. And that's probably where our focus is going to be, at least initially.
Brilliant.
Just one thing to add to that, Floyd. Sure. So I think, I completely understand the focus. I guess we are probably one of the few companies who are looking at baseload power from a hydrogen perspective, because we're building a CHP on our site to do that. I would say, obviously, for a large scale site like a refinery, CHP that produces both power and steam from a low carbon source like low carbon hydrogen has a huge amount of value for us. And that's primarily the reason we're doing it. And it is economic and efficient to do so compared to, to the previous equipment that we have. But I understand that obviously DESNZ can't think about this on an industrial site by site basis, right? So the focus has to be on the energy system as a whole. I guess the only thing I would say is building out large scale infrastructure for hydrogen across HyNet or other parts of the UK. If the hydrogen is available and there is value to support, baseload power generation, which is more primarily kind of on industrial sites, then that's probably not one that should be necessarily discouraged if it has value in that region and it can generate the decarbonisation impact that would be required. But on a case by case basis, it might have value.
Sure.
If I could add to that as well, that would be useful. I agree with what Marta's saying. I mean, I think from a system level perspective, I mean, we're looking at in our portfolio a sweet spot of projects or new projects in the sort of 50 megawatt type scale, largely to be under the DCO limit, albeit we are looking at opportunities slightly bigger than that as well. But I think there are opportunities for hydrogen blending into some of the larger existing facilities like ESB's project at ESB's existing power station at Carrington, where you've got an 800 megawatt or so plant that can operate that already is in the market, and you've got a lower cost option to use perhaps not, or certainly not 100% hydrogen initially, but lower levels of hydrogen, and blend that into the with natural gas and use that in that existing plant at lower cost likely than building a new plant. That can have quite a big system impact. I do think there's an opportunity for on-site power. We're looking at a couple of opportunities with data centers. Obviously, in the news, quite a lot of power. We're looking at potentially providing base load to those. That would be probably outside of the H2 ppm. It's not what the H2 ppm is set up to do. We might be able to do that in conjunction with a capacity market contract, albeit more likely we'd be a backup form of generation alongside a CM contract. But those are the kind of business models that we're looking at the moment.
Yeah, sure. Thank you for covering that off, guys. And just to stick on to Northwest at the moment, obviously, Great Manchester Combined Authority has got devolved power, and they're working on their own updated hydrogen strategy too. So just a question from a DESNZ perspective is how important is it that we kind of have these joined up approaches where we've got the buy-in from devolved powers that can really help push and they understand the local landscape, such as HyNet. How important is it that we have these joined up strategies both from central government and devolved?
Yeah, I would say really important, as you might expect. We work really closely with our counterparts in devolved governments and territorial offices. So yeah, I can't say much beyond it's as you'd imagine, important given the scale of this infrastructure to working really closely with our partners across devolved administrations. Matt, is there anything you want to add on that?
No, I think that covers that. I think, yeah, fundamentally, obviously, we work closely with the devolved governments, both in the devolved administrations and in local government as well. They have a clear role to play. Obviously, namely in sort of the planning system as well. These projects can't go forward without their support in delivering those quickly. We've had regular conversations with local government about initiatives that they're looking at as well. And I know we've spoken with the Manchester mayoral authority and some of the ideas that they're looking at, which colleagues might be aware of. So yeah, I think obviously like they have a key role to play. Yeah, completely agree with what Jess said there.
Yeah, sure. And Adam and Marta, is it great having, backing from combined authorities in the region where these projects are happening?
Yeah, I mean, if I could come in first, I mean, yeah, I mean, the Greater Manchester Combined Authority, the consultation you mentioned, something we're responding to. I mean, where you've got a strategic planning body like that, putting out a strategy, it's really important that I mean, it's not. I guess it'll be a different division from the sort of the planning function, but having that integrated sort of consideration of hydrogen and making sure that that strategy is consistent with what they're saying at a strategic planning level when they're zoning land, for employment, for energy, and etc. That's quite important, particularly, for us. We have a project within the city region or city area of Greater Manchester, so that's really important that they're putting that out there and are supportive of hydrogen. It gives us the confidence to move forward into what can be quite expensive planning and permitting processes, alongside all the engineering wider project development activities that we have to go through.
Yeah, sure. And Marta, I'll give you the final word on that question.
I think Adam summed it up nicely. So
yeah, no worries. So I've got a question coming on public and private finance, how it kind of can work together to de-risk early projects, especially whilst building wider investor confidence for later waves of funding. Do we see that as a big bottleneck at the moment, and kind of what role could GB Energy and the National Wealth Fund play in kind of like crowding in private finance? Maybe from an industry perspective first, Adam and Marta, and then I'll let the guys from DESNZ have a final word.
Yeah, I mean, I guess I think definitely a combination of public and private finance is definitely necessary and very, very valuable. I think the current expected role of GB Energy and the National Wealth Fund is probably more on that monopoly infrastructure, so on the hydrogen transport and storage, which essentially is fundamental to enabling hydrogen to power. Kind of that's where I think one of the critical roles will be and really should be, because it will be monopoly infrastructure that has value to many participants. I think the role of public finance coming in for individual projects will obviously vary on a case-by-case basis, depending on what the scenario looks like. I think the one thing I would say is some of our experience has been that some of the public institutions maybe are more risk averse than private institutions, and that doesn't necessarily to the partnership in the way that one would expect. But I think it's a bit of a process, right? A lot of these business models and the projects behind them are new, they're first of a kind. All of the lenders, whether public or private, and all the kind of companies sitting behind them have to go through the same process of understanding, the risk balance and understanding how that should be best placed with those who can manage it. And so I think there's still a process to get to the optimal balance here, but I think it's definitely very valuable to continue those conversations going forward.
Just to add to that, I think Marta's right. It's very, very much a case-by-case basis in terms of the type of project and what risk coverage you're looking for, but also very much the stage a project is at. I mean, that National Wealth Fund, for example, has come in and provided 29 million to the Peak Cluster project that Progress originated. That's taking CO2 out of the Peak District, and that the minerals industries there, cement, etc., and lime, whereby they can't easily otherwise decarbonise that. They've stepped in to provide sort of material DevEx there, which others weren't willing to do, and that's been that's fairly critical. I don't think that would have come from the private sector. When you get, for example, when you're sort of trying to get a hydrogen to power project or a green hydrogen green hydrogen project over the line, It is horses for courses, and it depends, on their view of risk coverage. In a lot of cases, perhaps there may be less of a role for them where the risk can be covered by the private sector. You won't be short of investors if you've got your contract in place, whether that's H2 PPM or whatever. But where there are some more challenging risks, maybe or maybe not. I think our experience is perhaps that, as Marta said, they're less willing to step in where you might have thought that was their role to come in. But I think it really depends on that specific project.
Yeah, thanks for covering that off. And Matthew and Jess, from a DESNZ perspective, maybe you can come in on the role of GB Energy and National Wealth Fund a little bit more.
Sure, thanks, Floyd. I very much agree with what Marta and Adam said there. I think a case-by-case basis is absolutely right. From a strategic approach, I think we see the business models as the way of bringing forward hydrogen initially, fundamentally, in part because that there are those economic and commercial barriers that the partner agencies like the National Wealth Fund and GB weren't really set up to address directly. I think what they've been designed for is adding liquidity to the market, really, particularly on the National Wealth Fund side, and they look at things on a commercial basis, but they might, like Adam said, they might invest in things that the private sector more broadly wouldn't, and they're helping to bring additional liquidity. I think the business model is more fundamentally designed at focusing on the larger commercial barriers that are preventing projects from coming forward. And I think that we very much see the sort of potentially sort of projects working together. There's no reason why they can't approach DBE and the National Wealth Fund to look at sort of support funding, whilst also considering entry to the business model. I mean, we can say more on that in future about how those two things align. But I think they have slightly different roles to play in the system, which is the key thing. But hopefully complementary roles as well.
Yeah, sure. That was an extensive answer there. So I'm not sure if Jess has anything to add onto that. Brilliant. Yeah. So if I may, I'd like to move on to the fact of another question that's come in, and whether hydrogen should be seen as a mode of energy storage. Obviously, we've got so much curtailed wind energy at the moment, and I think costs north of £1 billion. So could hydrogen be seen as a mode for energy storage? Is that something DESNZ is looking at?
Yeah, absolutely. I think what lots of our publications to date have done is highlight that role. So Clean Power Action Plan, various NESO publications, our own consultation. We are very conscious of the value that hydrogen power can play in that sort of energy storage role, using curtailed electricity and electrolyzers to store energy, and then burn it, I guess, use it when demand is particularly high. I think that's one of the unique value or benefits of hydrogen power. So yeah, we are very interested in the role that hydrogen power can play in that regard.
Yeah, sure. And does the sector have enough orchestration at the moment? Because obviously we're still just trying to build and get a lot of hydrogen projects off the ground. Using H2P for energy storage. It sounds like the answer to all of the curtailment problems, but there's a lot that goes into that. So one, have we got enough orchestration? And two, if not, how do we have that more joined up approach? Maybe I'll come to all the panel on this one.
I think maybe the one thing to point out here is that options for hydrogen use as energy storage is not homogenous across the UK, right? It only works in places where you have, curtailed wind or wind power coming in large quantities, right? So it works well in Scotland, it works well in other parts of the UK. The challenge is that the places it works in aren't necessarily the places where you're expecting to initially have hydrogen infrastructure to transport and store the hydrogen that you've produced, right, from the curtailed power. So there's a bit of a potentially a gap between where the value would be of most use, or whether sort of the curtailed electricity would be of most use, and where the hydrogen could then be used going forward, right? And that's just a function of how we produce electricity and where the greatest demand is across the UK. So I think that partly kind of links to your second question, which is how can you get the right level of orchestration? And to be honest, at the moment, the orchestration is being done by DESNZ, right? And the strategic planning role is moving forward from a NESO perspective. But given that the reliance of all of these projects at the moment, from production all the way through to power business model for this conversation, is linked to competitive processes that DESNZ is running, the orchestration is essentially being done, system wide across the UK by the government. Of course, the plan in the future will be that could evolve and move outside of that. But I think at the moment there is probably not sufficient funding and also time and skills in some sense to orchestrate the perfect system across the UK in the next 5 years, right? It will take time, and you have to build it up in pieces and then connect those pieces together in the most logical way, in the way that's the most affordable and value for money across the UK. So I think it's probably one of those areas that's kind of underestimated in terms of how complex that is, and each of these pieces of infrastructure will take 4 or 5 years to build out in themselves. So I think it will take time, but directionally it's going in that direction.
Yeah, thank you. And Adam, I saw you unmute your mic there.
Yeah, just to add to that, I will say, in HyNet, the amount of storage being planned, it's big, and it's it is very material compared to other forms of electricity or energy storage that we have available to us. I think it's about 1.3 terawatt hours that is planned in the underground storage caverns in the Cheshire Salt Basin, that the High Kuiper project that Store Energy is planning, and that's where natural gas has been stored in abundance in caverns for decades. So it's a proven way of storing hydrogen, and it's fundamentally important for the hydrogen system and enabling hydrogen's power where there are big swings in load on the system, and to be able to cater for that kind of storage is essential. I think in terms of curtailment of things, storing hydrogen from and producing it electrolytically, I think that will come, and I think we need to get the sort of storage in place to facilitate that. But at the moment, you have got a chunk of curtailed wind, but getting sufficient load factor on your electrolyzer to make it worthwhile, the investment, is difficult. The strategic sort of planning policy statement of hydrogen that's been, I think, was published a few weeks ago from government is interesting, and I think that effectively passes or is signalling the passover of powers to NESO for strategic planning in respect of hydrogen. NESO is going through a lot of processes that I don't know how many different RESPs and things, and they're consulting on at the moment. But I think critically in that document, government recognises that there is a role for NESO to play, and that is important. But there will be some potential conflicts, as it were, between what NESO suggests in that strategic planning and what the market delivers via the competitive processes that DESNZ is running. So I think that there'll be some interesting sort of outcomes in that regard. But it sounds like there's some pragmatism in government in that regard.
Yeah, sure. And from a DESNZ perspective, maybe as the chief orchestrators in this at the moment, I wondered if you had any final thoughts from what Marta and Adam had mentioned.
Just to agree with what Adam and Marta have said there, really, I think they're absolutely right. There's the long-term vision, which I think we all see NESO have demonstrated as well. So the modelling shows that there's a clear role for energy storage, and that's something unique that hydrogen can provide. And in the world that we're right now, so the energy security benefits that gives, using domestically produced fuel, storing it, using it when it's needed, I think has obvious strategic benefits, and from a cost perspective the system as well. But I think it's absolutely right that we have to take a sort of pragmatic approach initially, that it's difficult to go from that idealized version of the world to be delivered in the next sort of couple of years or so. There's going to be a journey to go on to get there. So I think that's absolutely in our minds in government, that sort of there's a pragmatism that we need to take to get there, even if that's where we ultimately want to get to.
Yeah, sure. Thanks for coming out. And we've only got 5 minutes left, and we've got a couple of more questions to get through. But I just wanted to add a bit of an observation more than anything, because I think it's like within our nature to kind of beat down on the progress that we're making within the energy sector. But I was at an energy briefing yesterday, and I spoke to the CEO of Life, and he was explaining that obviously they're based in France and they've got loads of projects happening in France. They still see the UK as one of the most investable regions for hydrogen. So how do we kind of take this optimism that we are seeing from the outside in and kind of have a bit more optimism, you know, kind of internally, maybe from DESNZ's perspective, that one of you guys can pick that one up?
Sure. Yeah. I mean, well, I think the government has shown kind of continued enthusiasm and support for hydrogen. As I mentioned before, a refreshed hydrogen strategy is coming, and expect that to be a kind of a moment of enthusiasm, maintaining momentum, etc., without really being able to speak to its detail. But yeah, I think we are trying where we can to propagate those messages and to engage as productively as possible with industry, and explain our goals and our ambitions really clearly. So hopefully the refreshed hydrogen strategy will also serve to do that soon.
Yeah. Cool, good to hear. And then I'll just bring Adam and Marta in for the final word on our panel today before we close out. If there was one policy, investment, or innovation shift that would, you know, most transform hydrogen to power landscape from your perspective, do you have one on top of mind? Maybe I'll bring in Marta first.
I guess the one I think that could have the greatest transformation effect, assuming that obviously everything that the government is planning around, you know, production, TNS and the business models kind of go ahead, I think that the ability for H2P to access the capacity market probably has the greatest transformative effect. And that's because it gives the industry that optionality, right, where certain archetypes of H2P would actually rather access the capacity market than go through the hydrogen to power business model. And what it does is sort of, you know, slightly separate and de-link the kind of the competitive rounds which we expect to happen around the hydrogen to power business model, and allow project developers to actually access the capacity market at a time and a pace that suits them, and you know, in a known entity, right, that's slightly different. So I think that's probably one of the kind of key steps from a H2P perspective to become kind of future proof and allow that evolution to move forward.
Yeah, sure. Thank you for that. And Adam, I'll give you the final word on the panel. Hopefully, Marta hasn't stolen your answer.
I think Marta gave a very good answer. I mean, I think an investable business model is critical. You know, I think the CM would work. I think the consultation alongside the call for evidence is looking at different tiers of the two different tiers of the CM. It's not focusing, you know, it's a mechanism put in place to enable or to deliver security of supply rather than low carbon security of supply. But I think it could do that. It is investable. It's proven it hopefully could be brought to market pretty quickly. On the other hand, you know, an H2 PBM, if designed the right way, could deliver the same outcome. But we'd like, you know, either way, an investable model that enables us to get to market within a sensible time frame. But again, you know, coming back to my first point, we do also need the transport and storage business models to bring forward those infrastructures to facilitate hydrogen to power as well.
Yeah, sure. Thank you for that. And yeah, that's all we got time for today, unfortunately. I'd just like to thank the panel for your time and answering those quick fire questions. But also, yeah, thank you to all the questions that came in from the audience. Apologies that we couldn't quite get through to all of them, but I'm sure you'll be able to contact everyone on this panel with follow-up questions. So I believe now I've got to hand back to Tiernan.
Floyd, thank you very much. Can you hear me okay?
Yes, can hear you.
Excellent. My mic just decided to go kaput just as I went to turn it on there. I think we're back though. No, not much more from me. Thank you so much, Floyd, and thank you very much to all of the panelists as well. That was an extremely comprehensive chat. So thank you very much for engaging with all the questions. Yeah, not much more from me. Just to mention that you know, if you're interested in these conversations and the wider conversations around the energy sector, then please do consider checking out the rest of the episodes, first of all, in our Foresight webinar series, and also that Foresight event taking place next February, where we'll look across the energy landscape at all of these shared challenges and opportunities as well. But other than that, no, I think we'll leave it there. I think that's enough on a Thursday morning to be getting stuck in with. Thank you so much once again for joining us and sharing your thoughts, everyone. And we do hope to see you again in the future for future webinars and sessions. So thank you very much, and enjoy the rest of your week. Thanks, everyone. Bye-bye.